Hi there, somebody's asking about this on the discussion board. This is, let me adjust my mic here. This is the fall 2022 final. It's a multi-part center of mass question. You might want to check out as well my, on the last page of the test prep on 8.3, I do 2 such problems, and I then posted a video on that. So if you want more examples, it throws an extra little monkey wrench into the problem. Anyways, suppose A is part of the confusion, probably just the wording. Annulus means washer, but without thickness, within a radius 1 and outer radius 2, but they give a picture to help. Let B be the part of A in the first quadrant. So the annulus would go all the way around. So they're just saying this is B. And the question is to find the center of mass, assuming the density is constant. It says give your answer in exact form or in decimal form, which makes me think the answer is kind of messy. It mentions symmetry, so which is not obvious why that would even apply. And the only symmetry I see is on this line, y equals x, which suggests, or which tells us that x bar and y bar are the same. That's what that hint was about. It doesn't tell you what they are, but wherever it is, wherever that center of mass is, x bar and y bar are going to be the same because the region is symmetric. So that's what that was. It was trying to save your work a little bit. There's one other bit of savings, which is the area. Because you can do the area of the big circle is pi times 2 squared minus the area of the small circle. And so the area of the whole annulus is going to be 3 pi, 4 pi minus 1 pi. We're doing a fourth of it, so that means the area of this picture is 3/4 pi. So some of these questions, I think they're hard questions. I think the person who wrote it thought, well, at least I'm giving them the area. So you'd want to make sure you do that right away. Okay, so that's what's going on. Same thing happened actually in both of those examples from my test prep. So now we're down to one last thing, which is we either need to compute, because since x bar and y bar are the same, we either need to compute the integral from a to b of x, f of x minus g of x dx. And that would be if we're trying to get x bar, because x bar would be whatever this is divided by the area. Or we could compute y bar. You don't need to do both. Y bar would be 1/2 the integral from a to b of f of x squared minus g of x squared divided by the area. I don't know which one's going to be better when I look at this. I think whoever wrote the question was like, well, I'm giving them options. Now to the challenge. The challenge is what is the top and what is the bottom? And that really doesn't have to do with center of mass. So this has really become a question about regions and how we describe them. So that was the added challenge here. So I'm going to color the sides. And I'm going to ask you, as you move from left to right, what is on top and what is on bottom? Let me get some color here. So here we go. First, when you get to 0, green is on top and orange is on bottom. And that stays that way for a while. So if you're mowing the lawn, you just say orange to green, orange to green, orange to green, orange to green, orange to green. Oh, up until here, which is 1, it's orange to green. And now it's going to change. And so the big challenge here was, however I do this, whether I do this one or the other one, I'm going to have to do the integral from 0 to 1. And then I'm going to have to add the integral from 1 to 2. And that's because something is changing. In fact, we can highlight exactly what's changing. The bottom is going to change. This function is going to change. It's going to be orange, and it's going to be pink. And so when I go to set it up, you have to split it up. And so that's the challenge. Either way, whether you do it this way or this way, you have to split it up. So anyways, this is going to be X, and that's going to be top minus bottom, and this is going to be X, and it's going to be top minus bottom. The only one I know already is the pink one, because that is Y equals 0. That's the g of X. So now you have an added challenge, which is how do you find the equation for this side? Well, it's a circle. It's a circle of radius 2 centered at the origin. But we want it in the y equals form. So we are y equals the square root of 4 minus x squared. That's the top, and that's always the top. 4 minus x squared, square root 4 minus x squared. And now for the bottom. Over here, the bottom is a circle of radius 1. X squared plus y squared is 1. So you get y is the square root of 1 minus x squared. That's the bottom over here. So that really was the challenge. And I suspect that was a big challenge. The fact that the word annulus was there, a lot was going on. And now that I look at it, I'm realizing that that was kind of a poor choice, because I kind of like that if I did y bar, everything would be squared. So I'm going to scratch that. You could compute that if you wanted. But instead, I'm going to do the integral from 0 to 1, 1/2 of top squared. So top squared would be this squared. So what I just wrote was f of x squared minus g of x squared. And that's going to be 1 minus x squared plus 1/2 the integral from 1 to 2, top minus bottom. Top squared is this. Bottom squared is just 0. So you can either choose to compute this or compute this. And it looks to me like that second one's easier, so let's take a look. 1/2 the integral from 0 to 1. It's going to be 3. I'm going to simplify as I go. Ooh, do the x squareds cancel? They do, because it's negative x squared plus, so you just get 3 dx plus 1/2 the integral from 1 to 2 of 4 minus x squared dx. And so it's 3/2, because that's going to be, plug in a 1, plus 1/2 4x minus 1/3 x cubed from 1 to 2. Let's see. So we're going to do 3/2 plus 1/2, 8 minus 8/3 minus 4 minus 1/3. All right, I'm getting kind of tired of the calculation here. 8 minus 8/3 minus 4, so it's going to be a minus 4, and then plus 1/3. This is going to be minus 7/3. So it's going to be 3/2 plus 1/2, 4 minus 7/3, and on we go. I really want to factor out 1/2. This is just my own weird way of thinking about it. And I want to factor out 1/3. Ooh, factoring out 1/2 was really nice. Maybe I'll deal with that first. You can see how I do some avoidance here. Now I'm going to factor out 1/3, which will make this 1/6, and it'll make this 7. And I just have one challenge, which is if you divide 7 by 1/3, what do you get? 21. Yay, so this is going to be 14 over 6, which is 7 over 3. Whew. View. Don't have to make sound effects. That's just for fun. So I'm getting y bar is 7/3 divided by the area, which is 3/4 pi. I hate fractions within fractions, so I'm going to multiply top and bottom by 12. Why 12? Because 12 will get rid of 4 and 3. So this is going to become 7 times 4, which is 28. This is going to become 9 pi. And x bar is the same, which you can give as a decimal. Let's see how I did. Probably made a mistake, but hopefully I gave you the idea. Yay! I got it right. So the comment, oh, they did it the harder way. Oh, no, they didn't. They did both ways. First way is better. You don't need to do both. If you had time on the final, this is a problem where it wouldn't hurt to do both because then you could check your work.